Hey everyone! So in this lesson, we're going to look at solving simple exponential equations. Mostly we're going to look at how to solve them numerically using trial and error. And then I'm going to show you how to solve them graphically, which just means to graph them and then look right on the graph to figure out what the answer is. So the first example is we're going to solve the following exponential equation. 3x equals 5. Now, the way to do this is through what we call trial and error. So basically, it's like a guess and check. So the first thing I'm going to do is I know that 3 to the 1 is equal to 3, which is less than 5. So we need a number that's an exponent that's greater. So I try a different number. 3 to the 2 equals 9. So I know that my value of x, so we know x is between 1 and 9. Or sorry, 1 and 2. Because the answer 5 is between 3 and 9. So we need to have an exponent that's in between that. So then it comes the just guessing. So the first thing I'm going to do is I'm going to go halfway and do an exponent of 1.5. So you can calculate these on your calculator. And in this example, I get 5.19. Now notice that it is greater than 5. So now I've kind of made the interval a little bit smaller. Now I know it's between 1 and 1.5. So let's go a little bit smaller. So this time I'm going to try 1.4. And it gave me 4.65. So now I know that 1.4 is too small, 1.5 is too high. So I know that my number has to be between 1.5 and 1.4. So I go a little bit smaller in between there and do 1.45. And I get 4.918. So I'm going to go even. I'm just going to go up 1 to 1.46. 4.97. So go up 1 more. And the idea is kind of just to get as close as you can. And this one's 5.02. And so I would say it's approximately, the answer is approximately 1.47. Okay, you can also solve this graphically if you wanted. Now, down here, what I did is I went on to Desmos and I graphed the two equations. The first one I graphed was y equals 3 to the x. So that is that red line that we see here. And the second one I graphed is y equals 5. And that gave us the blue line that's there. So then you can go right on the graph and you can see that the intersection is right here. And if we go down, it looks like it's about 1.5. And so based on our graph, we can say it's approximately 1.5. Of course, the only way to get a little bit closer is to kind of zoom in even more. But again, like this kind of stuff, we're just approximating. So it's okay that it's not exact. We're approximating. Notice how they're kind of close. Our approximation off the graph is really close to our approximation when we did it by trial and error. Trial and error can take a little bit longer to do, but it can be a little bit more accurate than just following the graph. Depends on how you want to do it. Okay, so the next example I want to do is look at like a real life example. So you have your money invested in an account and it grows according to the formula, and I've given it to you here. A equals 1200 times 1.005 to the x. A is the amount of money in your account, x is the number of months, and 1200 is your original investment, and then the 1.05 is how it's going to grow. So it's asking you, after how many months will your account have $2,400 in it? So let's see how we can go about solving this. So we want to have this at the end. So in this case, that equals A. So I'm going to set up the equation properly. I'm trying to give you an extra $100. Okay, so 2,400 equals 1,200, 1.005 to the x. Now the very first thing is we kind of want to isolate x, so I only want to have this bracket. So I'm going to divide both sides by 1,200. And so when we divide, these will cancel. And 2,400 divided by 1,200 equals 2. Now basically we're going to do the same thing we did above, and we're going to trial and error. We're going to pick values for x so that when we do 1.005 to the x, we're going to get 2. So it may take a while again. So try a few. I'm going to start with 12 months because that would be a year. So and then I'll kind of go up by that. So 1.005 to the 12. And that's only 1 point. So that didn't get us very far. So I'm going to maybe do 10 years, which would be 120. So that's the hard part, is kind of starting off to try to figure out what it is. And this is 1.8. So I did get a lot closer, but it's still not close enough. So keep trying and I will come back and tell you what I actually got. Okay, so I crunched a few numbers. I tried 1.005 to 132, which would be 11 years, and it wasn't close enough. But then I did 1.005 to the 144, which is 12 years, and I got 2.05. So in this case, we could say that it takes approximately 144 months or 12 years for the money to double. Okay, I'm going to try to do an example on Desmos and post it to show you graphically how to do it with Desmos, if you want to check that out after.